I am Dr. Mahammad Rafi, Associate Professor, Department of Cyber Security at Institute of Aeronautical Engineering. Today I want to discuss about link layer addressing in a computer network. Link layer networking here, the outcome of the link layer addressing, by using this link layer addressing, understanding the role of the media access control addressing and its use to identifying the devices on a local area networks or any local networks for efficient data communication. So, applying ARP, address resolution protocol. By applying this address resolution protocol to resolving the network layer addresses into the link layer addresses for packet forwarding in a local area network. That means with help of this ARP and the protocol, mapping the network layer address to the link layer address over the same network. So this is the outcome of the link layer addressing. Link layer addressing. What is a link layer addressing? Link layer addressing, it is a method. By using this as the method, by using this as the technique, we can identifying the device. Here with this addressing now, we can identify the device on the same local area segment or a same local area link. That means here it is a identifying device means now with help of this the address link layer address we can identify particular the device. So that address here now we are calling it as a MAC address. Each and every device having its own MAC address. MAC address is not repeated to the two different devices. This addressing now which is ensuring that the data packets are delivering to the correct destination within the local area network. By identifying the MAC address of a particular device, effectively we can transferring the data packets to the whatever the device are estimated over the local area networking. So this is about the link layer addressing. And MAC. So MAC address, media access control address. Each and every device having its own MAC address. The manufacturer, while these are the computers now, the hardware, the manufacturers, smartphones, and the routers or the personal the PCs. Now each and every other devices, the manufacturers now which is giving the unique address, that is a MAC address. The MAC address should be the unique. Each and every device having only one address. That is most the common form of the link layer addressing. This MAC addressing, it is a most common form of the link layer addressing. That's why here with help of these the MAC addressing now, which is uniquely identifies and assigned to the network interface card. So it will be the MAC address can be assigned to the NIC cards of a device, whatever the device is there, such as it may be the computer or personal computer, or it may be the smartphone, or it may be the routers. Generally, the length of the MAC address is a 48-bit address. These are the address generally now we are writing in a hexadecimal notation. So this is the hexadecimal notation. So this is the MAC address of a particular other device. each and every device having the unique MAC address over the network. The MAC address is not repeated. The manufacturers, so like this, no, they will manufacturing the devices. Any computer machines or smartphones or routers, so uniquely maintaining the MAC addresses. MAC addresses now generally or usually hard coded into the device by the manufacturer. So they can sometimes be changed through the software configurations. Now with other softwares, these the MAC address sometimes it can be changed as per the. That's why this MAC address now we say it is a user friendly. They like this now. The manufacturers they will make the MAC addresses. Now they will set up the MAC addresses to the other devices. So generally, common type of the link layer addresses. Link layer addresses, the common form of the link layer address is a MAC address. That is a media access control address. It is a common form of the link layer addresses. The structure of the, if you see the structure of the link layer addresses now, which is having the 48 bits. From that the 48 bits now, 24 the bits, so which is identify the manufacturer of the network interface card. So from that now 24 bits for network interface cards, and the remaining other 24 other bits now which is uniquely identified by the device. Here is the device, each and every other device now which is uniquely identified, remaining 24 bits. That is a network interface the controller specific. Organizationally unique identifier. Organization, the structure is which is having two parts. One is a organizationally unique identifier, that is OUI, the first 24 bits now which is identify the manufacturer of the network interface card. Network interface card now first 24 bits will be given, and the next 24 bits now it is a network interface controller specific. That means now the remaining 24 bits are uniquely identified to device. Each and every device here which is the manufacturer which is giving the unique number which is not repeated to the same number is not repeated to the two devices. As per the user the convenient now, by using the some other software it may be changes. MAC addresses can be changed. Here types of these the link layer addressings are the unicast addressing, multicast addressing, broadcast addressing. These are the three types now we can use the addressings. In a unicast addressing now, which can be utilized for a single devices. So it will be assigned to the single devices now, one-to-one communication on the network. One-to-one communication on the other network now it will be utilized. And a multicast addressing. The multicast addressing now which is used to communicate with a group of devices simultaneously. That means now group of devices now it can be utilized. This is the multicast addressing can be used, and that can be utilized for the group of the devices simultaneously. So by example in Ethernet, multicast addressing now which is having the some other specific range that is 105E for the IPv4.x. Now it is a specific range is having in a Ethernet. That is a multicast addressing. Broadcast addressing. Broadcast addressing means now which is used for sending the information or sending the messages to all devices on the network. Whatever over this the network, over this local area network, whatever the devices is connected, for all the devices now at a time we can sending the other messages. That is a broadcast addressing. So this is the broadcast the addressing for the Ethernet. The broadcast example FF:/FF. So for Ethernet the broadcasting that can be utilized. This is the example for broadcasting address. So whenever now we are sending the group of the devices over the same network, it will be used. Broadcasting address can be utilized, and by utilizing this broadcasting address, sending the information to group of devices. And how this link layer addressing works. The example for link layer addressing is nothing but a MAC address. MAC address is a best example for link layer addressing. How it is the working? The working is first, data frame formation can be done with help of the link layer addressing. So this data frame of the formation. So when a device says that a computer or smartphone or laptop, when a device you are utilizing which wants to sending the data over the local area network, so now the data is encapsulated within a frame at the data link layer. That means now what we are doing now, over this the network, whatever the data is sending, so that should be the wrapped into the single unit, and by wrapping the data into the single unit, we can sending the data, we are transferring the data from one device to the other device. These the frames are which is including both the source and destination link layer addresses. Both the source address and destination address link layer addresses can be used. That is a MAC addresses can be utilized. Frame transmission. The frame is transmitted over the physical medium. Here the example is a Ethernet the cabling. So Ethernet the cabling, now these the data frames can be transferred to the all devices on the local area of the network, or the whatever the local network of the segment, or this segment. Now whatever the devices are connected, for all the devices data frames can be transmitted. That is the Ethernet the cabling frame, the transmissions can be done by using the Ethernet cabling. Next, address resolution. Here link layer addressing, with help of this link layer addressing, the address resolution can be done. The address resolution, now that means now mainly we can perform receiving the devices, matching the devices, or non-matching the addresses. So all these actions can be performed. Receiving devices. The receiving devices means now if you want to receive the other devices, first you have to check the destination of the MAC address. Media access the control address, now we have to check. By checking the media access the control, now we can receive the other device by identifying the MAC address from the respective device, from the unique, each and every device having the unique MAC address. That's why by identifying the destination of the MAC address, now from that other destination receiving the information and sending the information to the particular other destination. Here the receiving device which receives the information from the MAC from the identified MAC address device. Matching addresses. Matching addresses generally, now if the addresses are matched between the two devices, that means sending device and receiving device, MAC addresses are matched, then only the processing the frames or data frames can be transferred from that one device to the another device. If the addresses are not matched, that means the devices should be ignoring the data frame transmissions. If it is matched, data frames can be transferred from device 1 to the device other 2. If it is suppose if it is didn't match these are the addressing MAC addressing of this the particular the identified device, so the data cannot be transferred, that can be ignored. That means unless it is a broadcast or multicast the addresses. Address resolution of the protocol, ARP. Mainly these address resolution of the protocol in a link layer addressing, now which is work it as a When a device need to communicate with another device on a local network, but only knows its IP address. So it uses the ARP, Address Resolution Protocol. This address resolution are the protocol now which is mapping the IP address to the MAC address. IP address to the MAC address over the internet. Whatever the data is the transmitting over the internet. So these ARP protocol. This ARP protocol now it is very helpful now which is mapping the MAC address of the particular the device over the network, over the local area of the network. Now by identifying the MAC address, now the data transmissions can be done. That's why now, so which is ARP, these the protocols can be used for mapping the link layer address to MAC address. That is a IP address to the MAC address of a particular other device. And the significances of the link layer addressing. Here is what are the significances of the link layer addressing. That means MAC addressings or ARP addressing. Here the significances are local other communication, device identification, error handling. These three are the significances of the link layer addressing. So local other communication, that means now, so in this the local other communication, now the accurately data can be delivered with the same network segment without an unnecessary routings. Whatever the data is the transmitting between the two devices, the required routers can be selected. By selecting the required other routers, via that other required other routers, other important other routers, the messages can be other transferred. The messages can be sent from the device 1 to the device other 2. Device is the identification. So in this the device the identification now, which is the providing the unique identifiers. Unique identifiers. So for each network interface, are facilitating network management and security measures. This is the device identification. Error handling. Error handling means now whatever the data we are transferring over the network, now which is detecting the errors and managing the errors in a data transmissions at the data link layer. OSI reference model. That's why this error handling now, which is assist in detecting and managing the error in a data or the transmissions at the data link layer in a OSI reference model. OSI Open System Interconnection Reference model. Link layer address versus network layer addressing. What is the main difference between the link layer addressing and network layer addressing? Network layer addressing, now we are using the IP protocol. Here is the MAC address. Now we are using message media access control can be utilized. So it is a very crucial to the differentiate between the link layer addressing and network layer addressing. That means link layer addressing now, for example, is a MAC addressing is a link layer addressing. The scope of this, the MAC addressing, it is a local network segment. Local area network segment is a link layer addressing. And the purpose means now, this is why, for what purpose we are utilizing the link layer addressing means now, which is identifies the devices on the same physical or logical network. Here, the statics of the link layer addressing, generally it is fixed to the hardware devices over the local area network. Take this network layer addressing. The example is a IP addresses is a network layer addressing. The scope is global or across multiple networks. Global or across the multiple networks. The purpose is now which routes the data between the different networks and across the internet. That means can changes based on the network or the configuration. Here the dynamic link layer addressing is the static, and this network layer addressing is a dynamic addressing. Dynamic addressing means now based on the network or the configuration that can be the changes. That address can be changes. Here is the address resolution protocol, IARE protocol, now which is working as a gap bridge, which is the gap between the IP addresses and MAC addresses. That is the network addresses and the link layer addresses now, which is acting as a bridge. So by the translating the IP addresses to the MAC addresses within the local area network, within the local other network now, which is acting as a bridge now, which is mapping the link layer addressing to the MAC addressing of a particular other device. Each and every device having the unique MAC address for particular identifying for particular device and sending the information to that other device, particular the identified other device over the local area networks. The differences are in terms of aspects, and the differences between the link layer addressings and network layer other addressings. Here is link layer addressing and network layer other addressing. The main differences is, so in a OSI model, OSI reference model, this link layer addressing can be utilized at layer 2, data link layer. So that is a link layer. The name of this link layer is a data link layer. That is a layer 2. Layer 1 is a physical layer in a OSI model. Layer 2 is a data link layer. So these data at the level of this data link layer, now we can utilize the link layer addressing. Next, in a network layer addressing, so that is it is a network layer which is utilized at a layer 3. At layer other 3. The addressing, the length of this the addressing, here is MAC address, that is media access the control. So type of addressing here, it is type of addressing is a MAC addressing, that is a media access control addressing. So network layer, the type of addressing is a IP address, that is a internet the protocol address. So this is a type of addressing. And address length, in terms of this address length, the aspect in aspect of the address length, link layer addressing which is having the 48 bits. From that the 48 bits, 24 bits can be utilized for NIC interface card, network interface card, and the remaining the 24 other bits can be used for identifying the other device. Identifying the device. 48 bits can be, first 48 bits can be utilized for the manufacturers or assigned to the network interface card. Next 24 bits. Next 24 bits is utilized, assigned for the manufacturers are assigned for the identifying the unique, identifying the device. So for identification device, the number is given it as a unique number. So it is not repeated to the many devices. Only each and every device having the only one unique number. So the second part now, which is specified like the unique number. With this unique number now we can identify the other devices over the local networking. In terms of this network layer the addressing length is a 32 bit for IPv4 the protocol, or 128 bit for the IPv6 the protocol. Now if we are going to the communicating over this the network layer addressing, if it is IPv4 protocol, if we are using the bit length is the data length is 32 bits. Suppose if you are utilizing the IPv6 over the network layer addressing, now the data length is 128 bits. So this is the size of the data. And address of the formats. The address of the formats are the hexadecimal. So it is a link layer addressing can be represented, that is a MAC address can be represented in the form of the hexadecimal format. For example, here 001A, 2B, 3C colon 4D colon 5A. So like this now we can represent the MAC address of each and every other device. Decimal notation. Here is network layer addressing now. The format now can be represented in the form of the decimal notation. That is the IP address. For IPv4 now protocol, if you are using the IPv4 protocol, we can represent the decimal notation here. That is 198.168.1.1 and hexa format for the IPv6 protocol. In case of IPv6 the protocol we are using, now we are writing the mentioned the format addressing format array in a hexa decimal form. So aspect in terms of the scope of this addressing, link layer addressing, which is a local to the network segment, and scope of the addressing of the network layer addressing, which is a global. That means now over this the internet now the communication can be done. For that now we are utilizing the IPv6 and IPv4 protocol. By utilizing the IPv6 and IPv4 protocol, globally we can transferring the communication. That means globally transferring the messages from one device to the another device, or across the multiple other networks also can be transfer the messages over the internet only. Next, permanent or temporary. In terms of the permanent and temporary, link layer addressing usually it's a permanent. Link layer addressing is a permanent. Why? Because MAC address, once the manufacturer is assigned the MAC address to one particular device, so it is a permanent. It is not a temporary. And it is assigned by the manufacturer, device manufacturer. It may be the personal computer manufacturer or smartphone manufacturer or any laptop of the manufacturer. The address should be the very unique address. It is a permanent. And network layer addressing now it can be the dynamic. Depends upon the network the configuration. This network layer addressing can be changed. Suppose here IPv4 now, which is having one IP address now, it will be the change. Depend with the help of this, by supporting of these some softwares, it can be the change. Network layer addressing can be the change. That is assigned via DH, the CP or the static. Next, used by as aspect of the used by switches and other layer to the devices. Now here in a link layer addressing now we are using the switches, and layer 2 data link layer devices can be used. In a network layer addressing now we are using the routers, and other layer 3 devices can be used. That is a network layer. In OSI reference model, layer 3 is a network layer. Whatever that network layer are the devices that suitable devices can be used for data other transmissions. The purpose, in terms of this, the purpose now we take identifies devices on the same physical network. On a same physical local area network now, the devices can be identified. And here is the identify the devices across the different networks. Same network is not required. So the identification can be done over the different network. So it can be done over the internet. Here protocol used. In terms of protocol used, link layer addressing now, which is using the Ethernet protocol, IARE protocol, Wi-Fi 802.11, which is used. These are the protocols can be used in a link layer addressing. Network layer addressing now, which is using the IP protocol, ICMP protocol and routing protocols. That is a BGP and OSPF for the protocol. Next, address resolution. So link layer addressing now, which is uses the ARP to the resolving the IP addresses to the MAC addresses, and network layer addressing now, which is uses the DNS to resolving the domain names to the IP addresses. The communications, in terms of this, the communication now, which is limited to the local networking, local area networking, and which is facilitate the inter-networking the communication. That means the global internet, global other communications can be done. Here is the the forms or the full forms of the terms now which is we have used in a comparison. MAC address means media access control address. ARP means address resolution of the protocol. And IP address. IP address, the full form is a internet the protocol addressing. DHCP means here dynamic host configuration protocol. That is a DHCP protocol. And DNS means domain name system. And LAN means local area network. IPv4 internet protocol version 4 and internet the protocol version 6. BGP means border gateway protocol, and OSPF means open shortest path first. ICMP internet control message the protocol. OSI model, that is a open system interconnection model. Wi-Fi 8G 802.11, that is a wireless the fidelity. The IEEE 802.11 standard. So these are all the full forms now of whatever the we have utilized in the comparison of the link layer and the network layer. Here real-time applications. Link layer addressing where we are utilizing, that is switching and LAN communication. So switching and LAN communication, the application in a local area network. Switches, whatever the switches we are using in a over this local area network now, using the MAC address. With help of this the MAC address media access control now, forwarding the data packets to the correct devices. So this is a application. For example, here a switch examining the destination of the MAC address of incoming data frames, whatever the data frames are incoming. So which is decide which port to sending the frame, which port number to sending the frame, which is enabling that other port number, and by enabling that other port number other transferring, so within this office or other data center to the particular other device. And wireless networking also, it's one of the real-time application. Here is Wi-Fi networks. Any Wi-Fi networks now layer link layer other addressing can be utilized. So with this in a wireless networking now, the devices can be communicated using the MAC addresses. Using the MAC addresses now that can be connected to the wireless access points. By connecting the wireless access points now, the communications can be done. Here is the example in a smartphone connects Wi-Fi network. By connecting the Wi-Fi the networks now. So here is the communication now in a smartphones are the best example, which is connecting the Wi-Fi networks. By connecting the Wi-Fi network, while connecting this the Wi-Fi network now, the router which is using the MAC addresses, of the smartphone, whatever the smartphone we are utilizing to managing and directing the network of the traffic and from the correct other devices. These are wireless networking. And address resolution protocol. Mainly this address resolution the protocol, these are the protocols now which is used for mapping the link layer address to the network layer address of the particular other device over the local area network. This main ARP now which is translating the IP addresses to the MAC addresses, which is mapping the IP address to MAC address. By mapping the IP address to MAC address now, the data frames or the data packets can be delivered to the correct device over the Ethernet networking. Example, when a device on a LAN wants to communicate with another device, ARP protocol now which is resolving the IP address to a MAC address, which is mapping the IP address to the MAC address and delivering the packets. Here network security purpose also this link layer addressing can be utilized. MAC addresses, this MAC media access at the control now which is filtering is a very security measures. Why? Because now with this the filtering now that allows or block the devices based on the MAC address. If it is the MAC address is a correct now which is allowing to communication, if the MAC address is a wrong MAC address now which is blocking the device, which is not support for communication. Any organizations or home networking, so it can be utilized. This network security, the MAC other filtering can be utilized. So by utilizing this, the MAC other filtering now to their the Wi-Fi networks, by only allowing the specific MAC the addresses for specific the persons now, we can allow and accessing the network, which is improving the security the mechanism. Those those users are identify users. For those users only give the internet the connections with help of this network security, that MAC the filtering. Load the balancing in a data centers. So load balancing any data centers now, load balancing purpose now, this link layer addressing can be utilized. MAC addresses are the used to distributing the network traffic over the on a servers while communicating the multi-client to single server communications. So that while communicating the multiple other clients with a single server, while distributing this the data. So at this the case now, this load balancing can be done in a data other centers can be arranged. So among this the server now, whatever the data is the transferring, the load will be balanced. Uniformly the data can be transferred from the multiple clients to the that whatever the devices, whatever the server device is there, for that the server device request can be sent. For the best example in a cloud environment is a best the example for the load balancing, or multi-client communication is the best example for the load balancing. Why? Because now load balancer distribute the traffic to the server. Client server communication also we can use the load balancing, so which is distributing the traffic, controlling the traffic based on the MAC addresses of the device, and optimizing the resources whatever you are using, and optimizing the performance of the devices. Mobile and IoT devices is another real-time applications of a link layer addressing. So MAC addresses are used in a mobile network, and IoT system also now we are utilizing the MAC addresses, and tracking devices also now we are utilizing the MAC addresses. Example, smart home environment, that is a devices like a thermostat, lights, cameras communicate with the central hub using the MAC address, that is a link layer addressing, which is ensuring the proper identifications and controlling of the devices, whatever the devices are working, whatever the mobile devices are working. The textbooks, these are all the textbooks, data communication and networking, and a computer and the networks by the Trojan. And here is the Tenenbaum computer networks by S. Tenenbaum and Andrew. So these two are the textbook for link layer and the addressing. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.